Hello, you absolute legends. Understanding whether a carbon atom is an alkane or alkene or alkyne can help us predict its geometry or motion that'll occur with it. This is an alkane hydrocarbon of just 5 carbons long. We call this pentane with an A because they're all single bonded carbons. Now, I don't have the hydrogens drawn in here just to keep this simple. But this carbon is only singly bonded to other carbons here. It is an sp3 hybridized atom right here. Now, what that means as far as its motion is that it can rotate freely around this single bond. This single bond is just like one chain. This can rotate freely on both sides and flip-flop around. Now, if we add a double bond to this and make it an alkene, we now have limited the rotation at this point of the molecule. We have sp2 hybridized carbon atoms, and these sp2 hybridized atoms, now the double bond is a little stronger. These are a little closer together because it's a stronger bond, but it also has limited rotation. This thing is going to wobble. So these are my double bonds here, and I'm trying to pick the molecule up and point it at you. It's just going to wobble like this a little bit. The double bond isn't going to allow it to make a complete turn as if it was a single bonded sp3. So that puts a rotational restriction in its motion. If we take this one step further to an alkyne and create a triple bond, we have now limited our rotation even more. This bond is a triple bond, so it's shorter, it's stronger, it's harder to break them apart, but it also has, these are sp hybridized carbons. But these carbons now with the triple bonds are even much harder to turn and much harder to torque, and getting them to do any kind of wobbling would take a lot of energy, things like that. So the understanding the number of bonds that are in between the carbon atoms can give you an idea of the freedom of motion or lack of freedom of motion. I hope this helps. Thank you.